Hello, everybody. Thanks for coming and listening to me. Yet another talk on AI. Those images we just saw were generated with AI, apparently. Let's go visual with AI and speak about image generation with this tool in action with Stable Diffusion and ComfyUI. I want to generate images of yoga poses. Normally, my wife should be here next to me because it's a side project of both of us, but she couldn't make it, unfortunately. But in a way, she'll be present in the presentation. You will see why. First, I'm Raphael. I worked for Worldline for quite a few years. I'm head of DevRel, senior architect, open source expert. What is important here is I'm also a certified yoga teacher, right? Because, okay, Worldline, who knows Worldline in the room? Just right. We're in Belgium. Normally, people should know a little bit. Yes. We're in the payment industry, a major player. We have a lot of engineers. We do R&D, including AI, and we deal with heavily regulated transactional flow. But this is not the subject. The subject is I'm a yoga teacher, and with my wife, who is also a yoga teacher, a few years back, we created this website to share our knowledge on yoga and stuff. But we always had this issue with yoga poses. We wanted them to be precise, but we didn't want to use any pictures because it's a lot of hassle. You have to go in the studio and take the pictures and then say, the same T-shirt at the same time. A lot of problem. We can't use image from the internet also. So when GenAI came out like 1 year ago, we decided to give it a try. What can we do with AI and generate yoga poses, right? And because I'm a geek, these are my functional requirements, right? My non-functional requirements are I want everything to run on this laptop locally. So it's a NVIDIA GPU like 4070 and only 8 gigabytes of video RAM, and that's the limiting factor, right? And I want all the components that I will be using to be the more open possible, because I'm an open source guy, right? So this led me very quickly to Stable Diffusion, which is a family of open models that were born in Germany in 2021. So it's like 4 decades ago in GenAI time, right? They innovated the concept of latent diffusion that I will explain later on. Very soon, they also collaborated with companies, Runway, Lether AI, and then Stability AI, who finally hired most of the lead developers. And now Stability AI is the London-based startup that is the official maintainer of these models, right? I said open models because you can download them, you can install that, you can even fine-tune the model, but you might have some limitation about what you can do or cannot do with the model. That's why I don't say it's open source, it's open. But this openness allows the rise of a very, very dynamic community sharing models, fine-tune models, tools, tips, tutorials, a lot of dynamism over there. By the way, if you want to understand better what is the difference between open weight model, open data, open science, open source, openness of a model and stuff, in this very room tomorrow I have a talk dedicated on that, right? So back to image generation. I also selected Comfy. That is an open source tool this time, a GPL v3 license that you download and install on your PC. And it is very useful because it puts a UI in front of the workflow that you could build in Python to use Stable Diffusion. It's very intuitive, modular, very customizable. You can do simple or very complex workflow, and it's also community-based, meaning that it's extensible with the notion of custom nodes, kind of plugins. There's a lot of people contributing custom nodes, so you can do a lot of things with this tool that becoming more as a platform for me, not only a tool. And actually, some people are running Comfy as a service right now. Okay, so I did selected Stable Diffusion as the model, or the family of model, and ComfyUI just to do some no-code and graphic creation of workflow. But let's start with a demo. So what I did, I recorded all the demos on this very PC, but then it's recorded because, you know, demo gods, but also because I have to accelerate sometimes the generation time to fit in the 30 minutes and not the presentation to be too boring, right? So here, we are in ComfyUI. I don't know if you can see properly. Oh, yeah, it works a little bit. Yeah, so we are in the UI of ComfyUI, right? You can see nodes that I interconnect with links. It's very graphical, all right? So here, I connect this node to this other one. Here, in green, I have the prompt. In the prompt, basically, I write what I want. So a girl doing yoga, lotus pose in a park, whatever. There is also a negative prompt. Then it goes to this specific node. We'll go into the details of the node later on. Now I just want to see this part is not accelerated. So this is the real time, right? So you can see the image emerging step by step in the middle node. You can see the consumption of the resource. A lot of VRAM is used. The GPU stuff is broken. Normally there should be also GPU used here in the bottom of the screen. And then you see the result. Here we are. I have a girl. She's doing yoga, maybe, in a park, right? So how does it work? Yeah, as you saw, it's a step-by-step process. It starts with a completely noisy, random image, like the snow on the TV screen, you know, when there's no signal, right? And then step-by-step, it will denoise the image, remove the noise, and replace it by features that are guided and that want to be aligned with your text prompt, right? Actually, Stable Diffusion learned to do the other side, like how to noise images, and now what it's doing is denoising the images, right? Important part of that is the latent space, because even if you see here all the image appearing step by step, it's not how it goes. Everything is done in a mathematical, vectorial, multi-dimensional vectorial space. Pretty much like LLM, actually, right? So it's a compressed version of the image that is represented into this mathematical space. And there, in this space, you have all the matrix calculation. So it's all about GPU's matrix calculation, just like a LLM, right? So once the image is finished, then it's encoded back into pixels. So the model is not working on pixels. It's working on vectorial vectors, or vectorial dimensional information. Right? Let's focus on a few of the nodes that we saw in our very simple first workflow, just to explain just a little bit, not too much. Models, right? Most important part of the stuff, obviously. So models, what will they be? There will be files that I download. Actually, it's the weight of the model, so the result after the training of the model that I download and I put on my laptop. And then with this node, I will select the model I want to use, and then ComfyUI will load the model into memory and then start using it. Right? The most used model by the community, the versions in Stable Diffusion family are Stable Diffusion 1.5 and version XL. They have a lot of fine-tuned models that are provided by many people and communities. You can have some of them on a regular generic website like Hugging Face, but you also have a dedicated website to image creation like Semeteys. And here, for instance, you have some of the categories that are used on Semeteys to sort out the model. So you have a lot of things possible, right? The other important node here is the prompt. Okay, it's using another model that is called Clip, developed at the same time, 2021 by OpenAI, right? And basically what it will do the correspondence between the text and the features of the image. So it understands the prompt and then it will guide the generation. Right? You can have a positive or negative prompt, what you want, what you don't want in the image. And you can have a textual syntax where you make a sentence, I want a girl doing yoga, sitting cross-legged and with blue hairs and blah, 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 blah. Or you can have a short syntax with keywords separated by commas. And you can put some weight with the brackets around to put more weight on a specific keyword, right? Another important node is the case sampler. That's where the denoising process occurs. So you see, it's very visual. You have a lot of graphics, and it's very easy to use. But in the background, there's Python running, obviously. especially in this node, right? So the denoising process is guided by two different kinds of algorithms. The first one is the sampler that will guide how the image is, the iteration process, right? The scheduler will control how the noise at each stage is removed. So you have several algorithms possible, and you can play with that. It will depend also on the model that you use, obviously. But you have a lot of possibility there. You also have other settings that you can tweak them, the tweak, like the number of steps, so in how many steps the image is generated. So you could think the more step I do, the more quality I will have. This is not true. Then it's called overfitting, and then the quality can decrease also, right? You can play with CFG, the guidance. Basically, it's the impact of the prompt into the generation process. And you can play with the percentage of denoising. So it's the percentage of the original image that will be removed, right? Of course, if you start with a completely noisy image, you'll want to denoise 100%, of course. The seed, actually, is the element, the random element that will generate this random image. And there is something that very important to understand here, is when you fix the seed and when you fix all the parameters in a workflow, the same parameters, the same workflow will always generate the same image, always. It's pure math. There's no magic. Everything is going on in the latent space, same parameters, same output, right? And the guys who did ComfyUI are very clever. Because of that, they injected all the workflow information into the EXIF metadata of the image. It means that when you drag and drop an image on a ComfyUI, if it has been generated with ComfyUI, you have the workflow back. So you're able to reproduce the image. Interesting, eh? So, okay, in this very first workflow, what can we do? It's a text to image. I put a text description and I have a result. So obviously I can tweak the prompt. So yes, I can change the color of the hair, the output, the clothes and stuff. I can go even further if I want to play with the prompt and use textual inversion technique or embeddings. Basically what are embeddings? It's just a shortcut, a predefined file made by the community or yourself, all right, to orient the prompt, inject a predefined element into the prompt to have a specific action or style, theme, texture, pose, character, anything, depending on the embedding file you're using. So here, for instance, I have a list of embedding files with different styles, and then I just have to use the keyword in the prompt node in ComfyUI, as you see here, and then yes, the ComfyUI will apply and inject in the prompt all the elements, right? So it's very tiny files, so it's very easy to use. And then I fix everything from the previous workflow. I only change the embedding files, and then you see I definitely have some impact on the style, right? So it can be fantasy, comic, cinematic, and stuff. It just replaces prompt that you'll do like a long prompt like that, right? So it's cool. So I went back to my wife. I say, hey, look what I can do. And she told me, yeah, well, you know, maybe the style is good, but the pose, you don't have any control on that. Huh? By the way, lotus pose, the first one, as a yoga teacher, you should know, Raphael, that it's not a lotus pose. Yeah, I know. And this one, the tree, maybe it's because there's a tree in the back. I don't know. The other one, the camel one, I don't know. Maybe it's a bias, because she looks like Oriental. I don't know, camel, Oriental, I don't know. And the last one is completely hallucination. It's not the shoulder stand pose. And don't try to do that, actually. It's not a good one. Right, so basically, text to image, for my use case, is not enough. So what should we do? Move. Generate an image of a woman based on an existing image. I have to give something as an input and maybe to control a bit more the output, right? So that's what I did here. I just update my workflow and I put an image of myself doing a specific posture, all right? Here you can see, if I zoom on the prompt, I still ask for a girl doing yoga and with blue pants. I want her to have blue pants, right? So it's an image of me. I'm a man, supposedly, and I want a girl to be generated. So let's see how it goes here. Okay, you can see, yes, the pose is okay. But I think her name must be Raphaela. She really looks like me as a girl. Let's play with denoising. This time I say I want to denoise only 70% because in the first pass I did 55%. Why? Because if I put 100%, of course, the whole input image has no purpose, right? So you can see here, it's nice. I can have control on the pose, but if I play with denoising, maybe you didn't notice, but I did because I am a yoga teacher and the head is tilted. It's not in the axis of the spine, so that's not the right pose. Not happy, right? So I was kind of a little bit disappointed. How could we do? What would be interesting if I could extract only the element of the pose from the image, not the style, not the fact that I'm on this mat and with the background and stuff, and inject that into the latent space. And that's exactly what the control nets are. There are specialized neural networks that will help to extract certain aspect from the image and just use that and send it to the latent space. So you have different control methods depending on the control net. It can be structural, the texture, the contents, the abstract, etc. Let's have an example here. I update my workflow. The new nodes are in the blue box here. So I still want a girl with white t-shirt, whatever. So I have the description of what I want. Here are the nodes related to the control net. The image will go into a preprocessor that will do some image processing. Like here in this case, extract depth information from the image and then inject that into the generation process. You can see the depth image here that will be used. Here now, I accelerate things a little bit. Now it will be quicker. It's in 20 steps. And here I have the result. Yes, now the pose is OK. The background is a little bit funky. Let's play with the denoising value because I want to see how stable the image is. All right, so I put 75%. OK, the background is OK. The pose is still OK. Let's play with the prompt. Let's say I want the girl to be blonde, just to see if when she's blonde, the pose is different or not. And I tweak a little bit also the denoising value. I say, let's put 80%. All right. And accelerated again with my 8 GB memory. Here we go. So yes, basically now I have control on the pose. And by the way, you have different kind of preprocessors. It can be edge detection, color map, scribble, and whatever. The open pose one was promising, but not strong enough for yoga poses. It's more like for classical pose, you know, that kind of stuff. Not for my use case, but I discovered that because you can stack the contour nets. You can use several by using both edge detection and depth. Then I had a good control on the pose, right? So because I can do that, abstract the pose from the image, I can use abstract images. This is good because this is the method I was using before for my website. I use these tools. Just Sketch Me. It's basically a virtual mannequin, you know. So you make the pose you want, and then you can have the angle of view that you want because it's 3D. So you export it, right? So just update the workflow, and this time I put the abstract image as an input. I changed the model. I use Juggernaut, which is a fine-tuned version of SDXL. This time I have my 2 control nets for depth and edges, all right? So obviously, the more nodes you add, the more parameters you have to play with. It can be a little bit dizzy. Here you see the features, edges and depth has been extracted, and then, yes, I have this result. OK, that is good. I have control on the pose, and I have control on the style for the prompt. Very happy. I go back to my wife. I say, job done. I mean, requirement fulfilled. She said, yeah, that's very good. But, you know, on the website, we do sequences, right? And so we have sequences. It's the same girl that should be the pose. So she has to have the same face. I say, but that was not in the initial requirement. You really like customer, you know, like, never know. So I was like, jeez, man. And then I thought, I say, okay, let's stay motivated. I know that people generate deepfakes, you know, of celebrities. So it's possible to enforce the face of somebody. All right, so let's look into this direction. That's how I discovered LoRa. So LoRa is for low rank adaptation. Basically, if in plain word, it's an update of the model at runtime. All right, it has been pre-trained only to change a small part of the model, and at the runtime, when you use the specific keyword, the patch will be applied, and then it has been trained to do different kind of stuff like styles, pose, characters, or concept. Here you can see the style, different LoRa on the same workflow. But what interesting me is the character. All right, so let's test it Very, very simple workflow. Here in yellow, I have downloaded a lot of LoRa files. So I select one, a celebrity, a mysterious one. We'll see if we recognize her. The prompt, okay, I put the specific keyword to activate the LoRa at runtime, and then yes. And then I use a control net, but with a strength of only 10% because I don't want to constrain too much the LoRa because I really want how good it is to generate the face of the celebrity, right? So let's see. All right, here is she. So I don't know if you recognize her, but in the name of the LoRa, Scarlett is in it, maybe. And by changing just the file, I can have a Emma or a Megan. Right? So you see the pose changes because it's only 10% on the control net. So you always have a trade-off and you have to play with a lot of parameters. But with that, yes, okay then I can do that very easily. I don't even showing you the video. I just had my LoRa here and then the result, I have a control on the pose and on the face. So there I go back to my wife and I say, yeah, job done. Now I can decorrelate both face, pose and style. So I have the variation, and then I can have the homogeneity. Then here is your sequence, and there is another one. So I was kind of excited, and she looked at me and said, yeah, that's good. I say, what's going on? Say, Scarlett won't be happy about that. I say, I know, but, well, you know, it's not really looking like her. And so that's the trick. You could put 50% of Scarlett, and then 20% of Megan, and then, 30% of Emma. Right? They say, no, you know it's not proper. We have to do our own LoRa. So I tried that. Okay, first thing, online, in a SaaS mode with Google Colab. With the Dream Booth technique, the results were not that good. Actually, my wife was not happy at all because she asked me, who is this ugly girl? I say, it's supposed to be you because... So she was not happy. All right, okay, look, back to my initial NFR. Let's do everything locally. I changed the strategy using Koya SS, open source framework to do that. And I injected less images, but more epochs. Then I got this result. So with this result, yes, I can update my workflow, and I have an interesting image. By the way, I added a note here, specialized with an associated model just to remove the background, right? It's just to show you that you can do more and more complex workflow. I'm just staying on a very simple one here. So with that, yes, I can have the sequence. And when I was going to my to the meeting with my wife, right? And in my mind, I was like, the quality is not that good. I mean, maybe I should have trained more. I preferred the Scarlett LoRa. This one is not very good. But she killed the solution definitely when she asked me, okay, that's nice. Let me see what it does when you use Cheyenne. Cheyenne is a model that is specialized to generate comics, graphic novel style. And I say, do you have 3 hours and a half? Because I have to go back and train everything, because it depends on the model. And she told me, Raphael, it's not possible. It's not realistic. All right. So I looked again, and I said, okay, are there models, techniques specialized on facial identities? That's how I discovered Face ID. Face ID is an image prompt adapter. It's another technique. You can see it very basically as a one image LoRa at one time this time. So just one picture that you inject. And Face ID is specialized in facial recognition, right? So I also discovered, while looking for it, Face Detailer, which is a different kind of model because it's a post-processing AI model that is specifically trained to enhance facial features like nose, lips, facial expression, and stuff like that, right? So let's update the workflow, and this is the final workflow for my use case. Here you see the yellow boxes are new. I have a big one, but the blue one is for the control net. Now I really focus on the facial identity. Here there is the image of my wife. Here, the model, you have several versions. As soon as you use IP adapter and another component, you have a lot of parameters that you can tweak on the strength, when it starts, when it stops, and stuff like that. Here on the side, I have a Juggernaut model. I use also a LoRa, but it's just to change the style. I could have dropped this one, right? And then here in the blue box, you have the 2 control net. I just reorganized the workflow for readability, but that's all, right? So let's run everything. You see, pose elements are extracted. Now, things are going on, accelerating a little bit. Then I have the result here. So Good thing, but it's not finished because now the result of this first generation is sent to Face Detailer, right? You see, Face Detailer is also linked with Face ID. It means that it will enhance the features based on the initial image of my wife, which is very good. Here's the result. You see on the top, you have this white box. There's a model that detects the zone of the image where the face is, and it will change only that, which is good because I don't want it to do anything else. And here I have a node before, after. I don't know if you can see properly. I zoom a little bit. Before, after, so the quality is better with Face Detailer. With that, I'm okay. I said, yes, job done. Job done. This time, yes, I'm sure. So I went to my wife. I say, here we are. She said, yes, Raphael, that's fine. We're okay. I said, yeah, okay. Peace at home. It's really nice. And I'm happy. The quality is better. It's very, and I don't need to train anything. It's just a simple workflow. I'm very, very happy. And by the way, I can change the model this time. And the same workflow, same parameters. I just change the model, tweak a little bit the things, and then I have a completely different style. But I still have control on the pose. It's still looking kind of like her, but in a cartoon style, right? So here we go. And by the way, because it's only one image, I can also change persona and put an image of myself, right? And then it does that. Well, I have to admit, at least for me, not for my wife, of course, AI tends to think I am still the young guy I was when I started yoga many, many years ago. But whatever. That's not the point, because yes, I can do sequencing with that. So I'm very happy. What did we learn? To summarize, if you want to tweak images, have some creativity just with prompt and text to image, you can do things. But if you want to control more aspect of the images, you have to input something like images. So you can do image to image, but it's a little bit raw, a little bit gross. If you want to be more subtle, ControlNet helps you by extracting some elements only and sending them into the latent space. LoRa for facial identity and coherence is okay, but it's a lot of work. It's heavy, and finally the result, the quality, well, not okay, at least in my case. But with IP Face ID, and Face Detailer, yes, I was able to do something good. So, to summarize, my use case is implementable, actually implemented. We actually publish, because we used to publish yoga sequences in a yoga journal in France, whatever. And one of these sequences was generated by AI. The journal owner was so excited about that. All right, so we did. So we have accurate and consistent images of poses and sequences, right? And what I've learned, it's image generation is both a science and an art. It's a science because, as you said, as I told you, same parameters, same image. It's only a mathematical operation there, but the more nodes and the more components you add in your workflow, the more parameters you have, and then you're lost, So by trial and error, and you develop a certain sixth sense of thing, and then you say, oh, that's the LoRa. Oh, no, that's the embedding. Because my wife sometimes says, but how do you know? I feel it's like that. So it's also an art in that matter. Icing on the cake, by changing a few elements, changing a LoRa or prompt and stuff that was not in the initial requirement. That's a new feature. You can deal with inclusivity very, very easily with that kind of workflow, right? We started that 1 year ago. In the meantime, a lot of things changed in AI with the rise of new models, like multimodal models. So I was like, how do they stand regarding my use case? So I did try ChatGPT with GPT Image 1, Nano Banana in Google, or Flux in Black Forest Labs. For the test I did, it's not perfect yet, but it's going very, very quickly because you don't have the same level of control, basically. The ControlNet, the IP adapter and stuff. So I can't have both control on the pose and the face. For instance, the first image, never do that. It's not good for your neck, right? The second one, Nano Banana told me that my wife was a celebrity. I didn't know that. So I'm very happy. I'm married to a celebrity. So he refused to generate a face, right? But what they are very good at is editing feature. As soon as you generate the image, it's very easy to change. For instance, here I changed the format, I changed the color, and I said put Devox on the T-shirt of the girl doing yoga. Very, very powerful, right? So a lot of amazing things. Speaking about the future, what could be next? Video. what is video except a sequence of images, right? So I tried ComfyUI locally with one from Alibaba, a video generation model, and I feed the model with 3 images generated by the previous workflow. And I told him, generate the sequence between the workflows. So here's the result after many hours of computing on this. So here, second pose, yes. Yeah, she's happy, huh? You see? Yes, yeah. Right, so, yeah, that's possible. And just to wrap everything up, that's why I called this presentation the yoga of image generation, because Yoga Sutras is a very important text in yoga. And one of the sutras says the pose to meditate, to do yoga, should be stable, like stable diffusion, and comfortable, as ComfyUI. I was like, man, was it on purpose? I don't know. My mind was blown, really. All right, thank you very much. I hope that you learned a few things. If you want to get in touch with me, use the first QR code. And please, feedback is a gift. Give me some feedback on this very presentation with the second QR code. Right? Thank you very much.